I just noticed a couple of things that I didn't do correctly before. I just set my finished floor level to 3.2 and I set my live load to 3.5, so that's all correct now. It's important to note that you can come back into this page at any stage and make changes to the geometry, the loading, the deflection limits, and it will redesign your floor straight away. So once you've set these things, they're not inflexible at all. You can come back and change the bay sizes, the number of bays, whatever you want to, really. Okay, so we're going to go on to the Analyze and Design tab. The Analyze and Design tab is where the actual analysis of the floor takes place, and it treats it as a complete single structure. By that I mean it analyzes the whole thing and the interaction between the beams and the columns and so on. So you never have to calculate loads or transfer reactions onto columns. It just does all of that for you. So typically what we would do, we've got a few little issues here. So we've got some issues with our main beams. Our default size beam is not strong enough and it's actually failing. It's actually failing on deflection and on capacity, as we can see down here. A nice thing within the software is it will automatically choose the correct or least weight section that we need. So if I click on that, it says I need a 356 section, and down below it gives me the results. A section can fail either on deflection or on capacity or on both at the same time, and what it's done is choose the least weight section that will meet the criteria for both of those. It doesn't stop us choosing another section. All of our sections are in here. They're organized by weight, so we could go for a different section if we prefer to use it. Quite a nice thing to be able to do is just show the sections as they're chosen on the screen. The outer sections, the outer bays, they're not actually taking as much load, so if we optimize those, normally it will allow us to choose a different section. In this case, the section was actually okay, so it hasn't needed to change it. If I go to the one below that, I can go to 43, which is obviously less economic, and if I keep going down, soon I get to a section that fails, and it's failing on the outer edges. The reason it's failing on the top edge and not on the bottom edge is obviously the adjoining span is greater here, so it's getting more load onto that edge beam. So we'll just optimize that again. 305 section is very efficient, it's deep and it's also very light, so tends to meet the criteria on deflection and strength. Let's optimize our columns. Our initial column sizes are 100 square, so if we optimize, we can go to 90s on the inners. Let's go to the outers. We can go to 80 on the outers. So we're saving a lot of material in doing that. I've set my bracing. I just need to check my joists. My joists can go down to 170. Let's just show those labels. I could probably get away with a smaller joist on these bays. It depends on the detailing and it depends how the hole patterns are going to match up where we connect through these beams. We could reduce them in this area because we haven't got a compatibility problem there, but I'm going to leave them. I don't want to get into too much detail in this part of the worked example, but I will cover things like that in other examples. The software allows you to change the size within this area here to save cost, but the cost saving is not going to be very great on this particular job. Okay, the stair stringer, let's just choose a stringer. We can use any type of section. I'll just use a channel for now. It can be a flat or it can be a rectangular hollow section. That's absolutely fine. Okay, you'll notice this table down here. This is to do with the costing part of the software, As I said earlier, we've actually moved on from that, so I will be talking about that part of the program in other videos which are more specifically to do with quotations. But as you can see, it's telling us the exact price of everything as well as designing it, and the price just updates as we make changes to our floor. That's a fairly big topic, so we'll talk about that separately in another video. A couple of things we've got to do on this floor is we've got to move this column over, because you remember on the original drawing that was offset by 400 millimeters. So I'm going to do that. I'm going to go to my floor editor, which is where we do that kind of thing. I'm going to remove my bracing, because in order to move a column we have to remove the bracing first. I'll put it back in afterwards. We go to our columns, show our column numbers. That's column number 2. Go to column number 2 in the table, put in the offset, which is minus 400. You'll notice that because we're increasing the span, show my beam numbers, for span number 3, or beam number 3, it's failing. So we've now got to go back and resize that beam. Well, we just go to the beam tab. Here we can see it's failed. It's actually failing on deflection, we can see there. Okay, and let's just go and resize that. If I show the labels, you can see it actually update it. So we'll go to least weight section. It says I need a 28 kg beam, which is fine. I'll just update that. And to keep things simple at this column position, I'll make that the same beam. So I'll change beam number 2 to be a 28 as well. There we go. Other things we can do, either in the editor or on any of the other screens, is if we go to BP, it'll show us our bearing pressures below our base plates or below our concrete slab. We can show things like beam reactions. We can show column loads. All that information is very easy to display. This button just displays the original gridline system that we created. Other things we can do is we can change our joists. We can change our base plates. So if we wanted to increase the size of a base plate, we can just do that in here. And this allows us to put point loads on the beams, which we haven't got in this example. If I go to my report tab, this is where all the calculations are produced. So it's worked out all of our calculations for all of our beams. Go to my material summary. As I said earlier, we're not so concerned about quantities and pricing because we're actually doing a detailed design, but we will of course be covering that in the quotation part of the training. Quantifies everything needed within the floor. Go to the cutting list tab, and it gives us a complete breakdown of all the steel that's needed within our floor. Not only the steel, but also the base plates, and even tells us how many holes are needed within our main beams for our connections for our joists. Okay, what we're going to do now is export the floor to our drawing which we started off with in AutoCAD, and I'll cover that in the next video.